So problem number 5 states that two equally charged particles held 3.2 millimeters apart are released from rest. Upon being released, the initial acceleration of the first particle is 7 meters per second squared, and that of the second is 9 meters per second squared. If the mass of the first particle is 6.3 times 10 to the negative 7th kilograms, find A, the mass of the second particle, and B, the charge on each particle. So the first thing I did was draw a little diagram here. So equally charged particles, I just kind of assumed that they were positive. And then they're 0.0032 meters apart, which is 3.2 millimeters. I wrote our givens over here. So the acceleration of particle 1, which we're going to call this one particle 1 and this one particle 2. So the acceleration of 1 is 7 meters per second squared. The acceleration of 2 is 9 meters per second squared. And the mass of particle 1 is 6.3 times 10 to the negative 7th kilograms. So the first thing that we know is that the force on each of them is equal. And we know that F equals ma from Newton's first law. So that means that m1a1 is m2a2. Because if the force is equal, then you substitute mass times acceleration of each, and you get that. So if you plug in the values, we know 3 of these values, a1, a2, and m1. So we plug all those in, and we solve for m2, which is going to be 4.9 times 10 to the negative 7th kilograms. Then we have to try and find the charge on each particle. So again, we know that the force on each is going to be equal to F equals ma, so that's the mass of the first one, which we know is 6.3 times 10 to the negative 7th kilograms, times the acceleration. We're just going to do, for example, the force on the first particle. So we know that the force on the particle is going to be 4.41 times 10 to the negative 6 newtons divided by coulombs. So if we know that this is the force, we then use the equation for the electric force, which is K Q1 Q2 over the distance between them, to then solve for Q1 and Q2. So once we do that, we know K, we know the force, we know the distance between them. We get Q1 Q2 is equal to 5.018 times 10 to the negative 21 coulombs. And it says in the beginning that they are equally charged particles, which means that Q1 is equal to Q2. The charge on each of them is the same. Therefore, Q1 times Q2 is equal to Q1 squared. And then when you square root it, you get the charge on Q1 is 7.08 times 10 to the negative 11th coulombs, or 7.1 times 10 to the negative 11th coulombs, as it has in the answer sheet. Hope that helps.